Welcome to classes on physical chemistry, and today's topic is chemical kinetics, and it is the last class on chemical kinetics, higher secondary second year, and it is class number 25, and the class is of about temperature dependence of the rate and the collision theory. I know that maximum of the student of higher secondary second year they are in tremendous pressure because of their advent of higher secondary final year, but keeping in view of their exam point of view, I have prepared the class in such a way that you will be benefited a lot because I have capsulized the theories and concept in a very simple manner. Just you see and you will find a lot of things come in exam. Am I right? So minutely follow. Since the topic is temperature dependence of rate and collision theory, let me first explain what is temperature dependence of temperature, how temperature varies the rate, or what is the relation of temperature of the only temperature and rate, and then we'll jump over collision theory. So in the previous classes, I have already explained the temperature is nothing but is a temperature coefficient mu is equal to K25 to K35, means when temperature difference is 10 degree, means if we increase the temperature by 10 degree, the rate of the reaction increase by twice or thrice. Today I will explain the reason why, and we have written is mu is equal to K25 to K35. This is the initial temperature, this is the temperature after increase, and you have seen that I have shown you on maths taken from higher entrance exam that if to keep 2 is fixed and 10 is fixed, and what is the difference of temperature is given in your question, you write here. If it is 298 to 308, means 10 degree difference. So difference in temperature is above and 10 is fixed. So your rate has been increased by twice. Now, if the temperature is in temperature, the difference in temperature is equal to 40. Now, as per the rule, you just keep it fixed and 10 is fixed. What's the difference in temperature? Difference in temperature is equal to 40. So keep it here 40 is equal to 2 to the power 4. So rate will be increased as 32 times of the initial rate. So this is the simple way how you will find the temperature dependence of rate constant of rate. Now let me explain a little about Maxwell-Boltzmann theory. Maxwell-Boltzmann. Just we have drawn it a graph to show you the temperature dependence of and how it differs and how the rate changes. You see, this is the temperature at very high temperature. This is the ordinate. It is fraction of the molecules it represents, and this is the energy reaction coordinate. And you see, at temperature, this is the temperature. This is the temperature at 10 degree more. That is highest temperature, higher temperature than this one. This is higher temperature, and this is initial temperature. Now, what you see here is, now I am showing you one observation. So from the diagram we see that the fractions of molecules when temperature is raised to 2 degree, that peak is shifted or flattened towards right. Here the peak is in this way, and that when temperature is raised by 10 degree, peak is flattened, not in this form, it is flattened. Number one observation. Observation 2 is more fractions of molecules have energy greater than E naught. Means if you see that one point I have skipped, I have not written. If you see that that is the graph, the lower part, last part of the graph is in this way, and that area is covered with the molecule, final molecule, which have got activation energy. This is activation energy more than or equal to activation energy is that much of the molecule. Now, when temperature is increased by 10 degrees centigrade, we see that this is ended in this way. And if you now take the area, then you will find that besides this, that much amount of the molecule is excess. So it is T plus 10 degree area. When temperature is T plus 10 degrees area, initially this was this much, now it has increased by this one. That is the more fractions of the molecules have energy greater than E naught or equal to E naught. Am I right? Now, since the when temperature is increased, so number of molecules are having activation energy same or more than activation energy E naught is more, means there is more and more chances of collision and more and more chances of getting the product. When the more and more chances of getting the product when temperature is increased, means rate has been increased. That is, with increase in temperature, rate is increased. This is very simple explanation. In a short way, I have explained it already earlier. What is the effect of catalyst in activation energy? I will explain activation energy later on, bit by bit I am coming, but before that, along with temperature, I am explaining the influence of catalyst in the rate of the reaction. These are the some important influence of the catalyst. I will explain. I have written it here. The catalyst does not absorb in the reactions. It is known to you all, and it alters the path of the reaction. The path has been altered by catalyst in a very simple way. If you write it in this way, say, if this is reactant and these are product, this is activation energy without catalyst. If catalyst is used, then so before explaining this one, just let you see one thing. You see, if you draw the ordinate gives you energy, and this is the reaction coordinate, this is the reactant, this is the product. It is exothermic reaction. I will explain later on. So when catalyst is not used, the activation energy of the activated complex is formed here. In Arrhenius equation, we will going to explain it. Activation energy to reach that level, that amount of energy is to be needed, is to be absorbed. When catalyst is used, what's happened? The activation energy is lowered. So more and molecule get advanced forward, come forward for the reactions. So rate increases. So this peak activation energy, that much of activation energy is needed when catalyst is not used. And the activation energy is lowered, means that much, means less of this much of energy. We get the product with lesser activation energy. So catalyst lessens the activation energy. Am I right? That's why it has altered the path of the reaction. It has altered the path of reaction. It decreases the activation energy of the reactant. It increases the rate because more and more molecule will able to cross the threshold energy, and they will give you the product. Again, it helps. It increases the rate. If there is more and more molecules are able to get the activation energy in the activated complex, so more and more product will form, and hence the rate will increase. Am I right? And it helps in attaining the equilibrium of the reaction. It doesn't have any effect. It doesn't have any effect of equilibrium. It cannot change the value of equilibrium constant, but it helps in attaining equilibrium constant. And it doesn't have effect on equilibrium constant. It does not affect on del H for entrance point of view. It doesn't affect on del H. It doesn't affect on del G. Gives free energy. Doesn't have an effect on. Okay, these are very short. These are the things I have not discussed. I have given you point wise. You just learn it as see once and see the figure. You can understand. Am I right? So I have shown you two figures. One is Boltzmann, Max Boltzmann curves, and another is catalyst with catalyst and without catalyst. This chapter is very easy and very simple. You need not to learn by heart anything. Just you follow my class. Collision theory. Before starting collision theory, let me specifically mention 2 or 3 points. Maximum of you do not have the collision theory. The main principle behind the collision theory is on collision. Am I right? Collision. So it is applicable. This collision theory is applicable, is applied only for the gaseous molecule, not for liquid or solid, because liquid and solid has less chances of the collision or movement of the molecules, and it is not valid for reversible reaction. The reaction which reverts back to its reactant side, it is not valid, and it is valid for bimolecular or more molecules, but it is not valid for unimolecular molecules. These are the main thing you first know before starting collision theory. Am I right? So these are valid for gaseous, and it is not valid for the reversible reaction. It is not valid for bimolecular reaction, and not unimolecular. It is valid for bimolecular reaction and more, but not valid for unimolecular molecules. These things you should first know, and then we will proceed for collision theory. Let's see what collision theory states. We will explain in short because nothing is tough. These are the very simple things. Three factors in collision. So fundamentally, I have taken 3 points from the collision theory, which is very important. First requirement is that there should be collision for the reactant molecule to proceed for reaction. Number one. Number two, the number of molecules colliding per second per unit volume of the reaction mixture of the reactants is called collision frequency, and that number of molecule colliding per second per unit volume of the reaction mixture of the reactant is called collision frequency, and it is represented by Z, and the dimension of the collision that may takes place is equal to 10 to the power 25 to 10 to the power 28 for bimolecular reaction, not unimolecular. Mind that these things are very simple. You need not to learn by heart. Very simple. Now, number 3 point is that third point is related to, again the third point is very important. One is relating to orientation. Later point we will come orientation. Now you see, the effective molecular collision gives rise to the product, and ineffective molecular collision does not give rise to product. Means if the collision, if the first requirement, if the collision gives it takes place in such a way that these are effective. I will take one example. Effective, and that type of effective collision will give rise to product. Otherwise, ineffective collision, the collision which doesn't give the product. There is collision, but it doesn't give rise to product. That is called ineffective collision. One simple example. I am in short. I am going with trampoline. You have seen the trampoline. In trampoline, just when a small guy just make bounce upon the trampoline, and if he doesn't know how to maintain the bouncy of trampoline against the force of the trampoline, if the boy or the small baby act force against it, that he can't jump high, he will fall down. And if along with the bounce of the trampoline force, if he adjusts it, so he will jump higher and higher and higher. He will enjoy the jumping. Means if the collision, this trampoline making a pressure, if you assume it upward thrust, if you assume it is a collision, and the boy exerting a pressure is another collision. If that two collisions are in same direction, that it will make him or her high. And if the one of the thing is goes against another, till there is collision, he can't enjoy. Means if the collision is effective, then you will get product. If collision is not effective, you will not get product. So it's a very simple way I have represented as things. So NO2, say NO2, NO2 and NO2 is making collision. N and O is making collision to give you the product. So you see, one of these two, O and O, and these are in this direction. So when these two make a collision, that will make a disturbance, and that will make a disturbance here. So it will be scattered away. It will not form any product. Now, if these are in this way, one is in above and other is in this direction, then you see the effect of collision is the way of collision is effective, then you will get product. When the collision is not effective, then no product will form. When the collision is effective, it will form product. Collision, two things are to be cleared. So you learn in a systematic way so that you can understand the whole topic, and whatever the question will be asked, you can able to answer it from your own mind, application of your own mind. Nothing to learn by heart. So you see, whenever we are talking about the effective collision, so what you say that effective collision is again depends upon two factors to be cleared. If you have the effective collisions, there occurs effective collision, and that will give rise to the product. These two things are things to be cleared are energy barrier and orientation barrier. Now, what is energy barrier? Energy barrier means threshold frequency. I will explain it. And orientation, already I have told that if it is oriented in such a manner, the collision is effective. I have shown you. If the orientation is such a manner that collision is effective, then product will get product. So if two things are cleared, then there will be effective collision, there will be chances of getting the product. Now what's happened? What is energy barrier? Threshold energy. What is threshold energy? Here, if you see in short by diagrammatic way, I will show you. You see one thing. Here it is threshold energy, activated complex. Now, simple one example I am showing you that for Olympic competition, a high jumper should cross, say, if a jumper can cross 8 foot, then he will be qualified for Olympic. Now you see, a jumper already has an ability up to this level. The reactant means jumper has already energy. This is energy of reactant. They have already energy that this person has already ability to jump up to 5 meter high. So it has got some average energy. So that energy will not do to cross the limit of 8 feet to qualify for Olympic. Now what he need to do, that by practicing he should increase 4 meter is his normal natural ability to jump. He need to increase further 5 meter. That is, further 4 meter. 4 feet. 4 feet. So now that 8 feet is your threshold energy. You need 8 feet to cross in high jump to qualify for Olympic. So 8 feet is required, but he has already 4 feet ability, means average energy of the reactant molecule is already 8 feet. So you need 4 feet more by practicing. So that excess amount from the average reactant energy is called activation energy. And when this activation energy, average reactant energy and activation energy adds up to give the limit 8 foot, that is threshold. That is the final point to be touched for qualifying in Olympic. So 8 feet is the threshold frequency, and now that much of amount it has already 4 feet. He needs 4 feet more. Then 4 feet more is called activation energy. So amount of energy over and above the average energy of the reactant to reach that level is called activation energy. Activation energy is what is threshold energy? Threshold energy is equal to activation energy plus energy of reactant. So what is activation energy? Activation energy is equal to threshold energy. Let me write it E threshold. Threshold energy minus energy of the reactant. Now what is activation energy? 8 feet minus its average energy 4 means 4 feet. Am I right? So this is the concept. Now here this is the reactant and this is the product. This is the activation energy, and reactant and product difference enthalpy is called del H. You should be familiar with this term del H. I am coming with this. Sometimes question comes with del H. Del H is the difference of energies, difference of enthalpies of reactant and product. So reactant is here and product is here. That difference is del H. Sometimes it is termed as potential energy. Later on del Hp. I will explain it later on. So we have collision. We need to cross our clear barrier, energy barrier, means we should go up to the threshold energy. We should have possess some amount of energy, and that energy to get threshold energy is called activation energy. Am I right? So what is the orientation barrier? I have already shown that should be oriented in such a way that collision should be effective. So two barriers. This equation, Arrhenius equation, and everybody of you know, you have already learned this K into A into e to the power minus A by RT. I will explain it each and everything. Let me, what is Arrhenius? Who was Arrhenius? Arrhenius was a Swedish chemist who took birth in 1959 and probably died in 1927 and got Nobel Prize in 1903. And he was the pioneer to give the definition of acid base. Probably he is the first person to give the Protonic concept of acid which gives O place and base which gives minus OH. Protonic concept. Acid is the substance which has the ability to furnish H positive, and base is the substance which has the ability to furnish OH. He is the first person to propose the definition of acid, and he was Arrhenius. And Arrhenius also gave a lot of discussion regarding dissociation of electrolyte in the solution. So you will get in solution chapter later on. This is the very simple thing I have told you. Rate constant K equal to A into e to the power E by A. So he had added two things, A and EA, in his activation energy, or EA, you can write EA, activation energy, and these two terms are called Arrhenius factors, where, so in detail I have written K is equal to A into e to the minus A by RT, where K equal to rate constant, you know it very well. A equal to collision factor, collision frequency, you can't explain why it is called frequency. Since there is collision, when there is a collision, these are the very tiny particle, there is a frequency, that's why there is collision frequency. I will explain it later on. Rate constant, collision frequency, that may also be termed as steric factor, that may also be termed as P exponential factor, that may also be termed as Arrhenius factor. Am I right? And E is the activation energy, R equal to gas value is equal to 8.314 joule per Kelvin, T is equal to temperature in Kelvin, E is equal to log base, it has come from log, and that value is found calculated and found to be 2.7. And also this part is called, sometimes here this part is average energy sometimes, because RT is there. So in the first year you have got it average. Anyway, I am not making complicated the thing. So e to the power minus E by R2 again it is nothing but the fraction of the molecules having activation energy, having energy more than or equal to activation energy. These are the fraction of molecule. So Boltzmann constant, I have drawn a figure where I have I have forgotten to mention these things. So this is something about the Arrhenius equation terms, and that's why I am taking these things. Derivative form of Arrhenius equation, you need not to practice it. For entrance of point of view, I am talking a little, I will take only 1 or 2 minutes. dln by dt is equal to E naught by A. It is the differential form of the Arrhenius equation. So if you arrange it, dln is equal to, you take dt here, E naught R is a constant term. E naught is a constant, as you were assuming E naught as constant. So E naught by R is constant 8.314. And if I take dt here, so this will be dt by RT square. On integration, what will you get? On integration, this will be for simple student, those who will appear for higher secondary final, this derivation is not important, it is not required. I have just shown for the entrance point of view, because things here I will mention a bit later on. See, the derivative form is dln k by dt is equal to E naught by RT square, and I have just arranged dt. I have taken dt here, dln k is equal to E naught by A, this E naught by R, this is constant equal to dt by d square. If you integrate this, so dx equal to x ln k, and this is constant, 1 by t square is equal to minus 1 by t, that I have taken minus plus integrational constant c. Now at time when E naught equal to 0, k is equal to A. I will explain it a bit later on. When E naught equal to 0, then this whole part equal to 0, e to the power 0 is equal to 1, that k is equal to A. When E naught equal to 0, k is equal to A. So if you put this value here, if you put this value in 1, E naught equal to 0, k is equal to A. So at E naught equal to 0, ln k will become ln A, and E naught by R, E is equal to 0, this part equal to 0, and C is C, then C is ln A. Am I right? So putting that value of C here, we write ln k is equal to E naught by RT is equal to ln A. So I have taken left side, so ln K minus ln A is equal to divided by. You know it, ln K log A minus log B is equal to log A by B. So I have written ln E base K by A. So this is exponential log base e to the power this is equal to K, e to the power this is equal to K, K is equal to e to the power E naught by AT. So at that point, C value of C E naught equal to 0, then K is equal to A. So in place of K, I have put here A, and that time is 0 C. Then C is equal to log ln A. So here I have put it. So this is in a very simple way Arrhenius equation. This is differential form of in your exam. You see, this is first of these things. First of all thing, I will tell when activation energy is equal to 0, then E of 0 equal to K into A, K is equal to A, means frequency factor is equal to A. When activation energy is equal to 0, means what is K equal to A? I will explain it. Again, if activation energy is equal to 0, that means every collision what does it mean? When activation energy is 0, means each and every collision will give rise to the product, but which is not possible in terms of our theory. In our postulate, we have seen that every collision will not give rise to product. Only those collisions which are effective will give the product, but it will go against the concept. E not equal to 0, every collision will give rise to product, but it is not possible. Am I right? So E not equal to 0, K equal to A, means frequency factor becomes equal to rate constant. At that time, rate constant is represented by frequency factor. So frequency factor becomes equal to rate constant. Number 3, if time is at infinity, very tricky things, you just follow, nothing to learn by heart. If time is at infinity, so 1 by infinity is equal to 0, that whole time equal to 0, e to the power 0 equal to 0, 1 by infinity 0, that term equal to 0, so K again equal to A. What does it mean? At infinite temperature, K becomes equal to 0, that is rate constant is equal to collision frequency. So next one, when T increases, T is here, when T increases, rate will increases, because this term is constant, 1 by T, bigger and bigger T, this is constant, say, so e to the power minus 2.7 to the power minus something, so you put the value of T, you increase and increase, you will find 1 by plus of this thing will be greater and greater. Exam question comes, what are the some factors which retard the rate of a reaction, which slow down the rate of the reaction? These are imperfect orientation and steric factor. You will answer it. Steric factors and imperfect orientation are the factors which slow down the rate of a chemical reaction. Now let me come to the another point. If you take log, so we will get ln K is equal to we get this. If you take this is multiplication, you know it, a log A into B equal to log A plus log B, so this power will come as coefficient. I need not to explain, you learn it. On taking log ln, we will get ln K is equal to E naught by RT by this. Why I have written, again it is very important, in sometimes a question asks in the exam, a problem asks in the exam, so you must learn to write the equation, this form of equation in logarithmic form. So here this is y equal to mx plus c form. That part is in y coordinate, and m is this, and t is variable, his x is variable, and this is constant. So it is y equal to mx plus c form, and you have all of you know that it is a straight line. So if you draw, again drawing is important, you mind that it is very important. Again you see, I have drawn it for your convenience, and sometimes question in entrance comes that whenever you will draw a graph in the Arrhenius equation, ln k versus 1 by t, find the relation of activation energy and gradient or m slope. So the relation is m at, yes, again let me explain. This is ln k, this is y coordinate. So y coordinate, here this point is here, at this point, that y intercept will give you ln a. So you will be confused. Many of you know, you just write in this way. The whole line is ln k, but this intersecting point gives ln a. Why it is so? You can't tell, maximum of you can't. Why it is ln k? That intercept means corresponding to this point is 0. So if in terms of energy, that I have drawn 1 by t, why it is 1 by t? Because there is 1 by t. When t is at infinity or activation energy is equal to 0, then k is equal to what? A. At activation energy 0, k is equal to a. So at this point in whole axis, here this point means it is lying 0. If it is 0, then k is equal to a. So ln k becomes ln a at this point. Hence this intercept gives ln a. Don't be confused. The ordinate y is equal to ln k, but that intercept is ln a. Why? Because at this point not 0, and that gives you k is equal to a, and in ln k you will put ln a, so you will get that intersecting point y is nothing but ln a. So what is y is slope equal to, I have already shown, slope x is 1 by t, and slope is minus E naught by r. So E naught by r is slope. So in the entrance exam, a line, a huge big question is written in this way, and you are asked to write the relation, and you will find the relation is nothing but E naught is equal to r minus rm. This is the relation. So why I have written in this way and I am explaining this one, again you will find its importance while I will explain some of the questions or problems. So I will solve out lots of problems. If it is not given, sometimes ln k and 1 by t is not given, you are asked if you draw k versus t, what will be the nature of the graph? The nature of the graph will be this in Arrhenius equation. I have done two graphs. I don't be confused. One graph here the coordinate, the reactant is in this way and product is much below in terms of energy, is less amount of energy is there, and here the reactant is this. Here means when reactant is transformed to the product, the energy is released and the product has lesser and lesser amount of energy. Most stable, it is exothermic reaction, and here you must have to supply some amount of energy to make the reaction feasible, and from reactant to product we get this, and from this reactant to product we get del H, reactant to product we get del H, this one. Am I right? So what we write here is very important. You learn it, you should learn it. So you see, what is del H? Energy of the forward. Del H means change in enthalpy is the forward reaction. Energy of forward reaction is minus to energy of the backward or reverse reaction. This is del H. Now, if del H is positive, it is very simple that this must be positive, this must be greater than this one. If del H is positive, this must be this is, and if del H is negative, this must be greater than this mark. So one is exothermic, other is endothermic. A question in entrance exam very often in your class appears in this way. Here you are getting you are given del H is equal to this much joule, and the smart energy is given kilojoule. In the figure you are given in this way 200 kilojoule, and del H is equal to this much, and it is drawn in this way, and you are given del H equal to, you are asked to find out E of backward reaction. So just to write del H is equal to E forward minus E of backward. Del H is equal to this much. Energy of forward equal to 150 minus E of backward is not given. You just put this one from this figure you will get. You don't be confused, and then don't be afraid of the figure. What figure has been given, so how will you solve it? This is very simple thing. I have explained one in a very simple way. Now come to the point in your state or entrance NCERT exam. One of the problem very often comes. Let me tell the type of the questions problem. One thing I have forgotten, that we can derive ln k that was the initial reaction. So if I take log, we will get 2.303. It is known to you all. So for two different temperature, if I assume T1, it will be K1, and if I assume it 1, I will not make it lengthy. If at different temperature, and if you subtract 2 from 1, we will get ln2 minus ln k1, ln k2 minus ln k1, that is ln k2 by ln k1, and this two E naught by R is common, and 1 by T1, 1 by T2. This is minus, I have taken this one, T1 by T2, T2 minus T1. So this is very important derivation. From this you will get a lot of questions from your exam. Today I will give you some hints and trick how to get the answer within short time. Each and every one can do this one, but you will arrange it before taking. So let us take log. What will log? Log of K2 by K1 is equal to E naught by R 2.303 R T2 minus T1 if I take log. Now to make your question easy, maximum in your exam, I will take one example. Exam, you are asked to find out energy of activation energy, activation energy. Let us arrange this to get this one, and we will give you some final result. Let us arrange. So what is E naught? E naught, E. If E is there, so that is log K. Log K2 by K1. Log K2 by K1 will remain same. When E is there, so that part and that part will be reverse. So I have arranged. So you always write in this way. E naught is equal to log K2K into 2.303 R T1 T2 by T2 T1. That will be reverse, and that will go here with multiplied. When E is, I want to calculate this one. This is very simple thing. You can do yourself. So E naught is equal to log K2 by K1 3.003 by T1 by T2 T minus T1. So what is the advantage of writing this equation in this way? You learn it in this way. So what the advantage you are getting here is, you see the value of these two, that is, it is rate constant 8.314, and this is 2.303, 303. So what we get here, just you take these two and these two, you multiply, you will get 2, 16, 19.1. You are getting 19.1. You learn by heart. You will each and every problem of this type, you will get these two. These two. 2.303 R value is this, and 2.30 is this. Multiply, you will get 9.1. Again, when the rate is increased twice, rate is doubled, rate is quadrupled. When rate is doubled, when temperature is raised 10 degree, rate is doubled, means K2 by K1 is equal to 2. Rate is 4 times quadruple when temperature is increased from this temperature to this temperature. Again, you are getting K2 by K1 is equal to 4. So two things you are getting. One is K2 by K1, 2. If it is double, if it is quadruple, K2 by K1 is equal to 4. So here two terms you are getting. If it is 2, you are getting log 2. So in the very beginning, I told you log 2 is equal to 0.3010, and log 4 is equal to double of this, 0.6021. So you are getting another term multiplied here. Along with 9 means 8.314 into 2.303, and if it is log 2, if it is twice log 2, you are getting 3010. So you have to do a lot of multiplication. So I have already shown you this is 9.1, this is 9.1, and this is 0.3, 0.3010. If you multiply, you will get 5.7. So if it is log 2, whole term is fixed, 8.314, 2.303 into 0.3010. If it is log 2, so you are getting this value. And if it is log 4, 8.34, 2.30, it is log 4 into 4. If it is 4, what you are getting? 8.314 into 2.303, and log 4 is equal to 6021. Need not to multiply, it is double of log 2. If log 2 is this much, so this will be double of 5 point this. What you get earlier is for 3.3010, it is 6021, so it is double. So what is the value you got? Log 2. If it is log 2, you are getting 5.7. If it is log 4, it is double of this one, it is 11.5. So two terms you are getting fixed. You keep it in your mind, while I will do without any, I can do very at ease. If it is log 2, we'll get the value 5.7, that part, this three part will be this. If it is log 4, then this three part will be 11.5. You learn by heart, you will save a lot of time. Let us take one simple example to explain this. So if I recall, one question was, if from temperature raised to 300 T, the rate becomes double. This is the question. When temperature is increased from 298 to 30 K, the rate is double. You are asked to find out EA. So what is EA? I have already written. EA is equal to log K2 by K1 2.303 into R T1 T2 minus T1. We have learned it earlier, we have arranged this one. So you see the beauty of maths. So this much is what? It is double, means it is log 2. Log, that value is 2 into 2.303 into R, and T1 is 928, T0 is this, and the difference is 10. It is known to you already. What we have already calculated out, this amount is equal to 5.7. Only you need to do what is, you find out the answer of this part. Am I right? Very simple. Now, if you are given two temperature, what difference is 40, and make it the rate is quadrupled 4 times. You are getting log 4. Same question here. You are getting same question. If temperature is like this, so 320 to 360, say to 40-degree difference, it is quadrupled. It is 4 times, and you are asked to find out the activation energy. How will you do? Again, you write activation energy is equal to this, and you write log k2 by k1 point into 2.303 into r t1 t2 minus t2 minus t1. Again, here you see the beauty of maths. Here it is log 4 into 2.303 into r. Only temperature is 320 into 360, and difference is 40. You need to do is this part, but that part log 4 is nothing but 11. Huge simplicity. That part is even that you do only this part, you multiply this, you do. Yeah. My last part of today's lecture is again very important, and you see minutely follow. Yes. Now another and last question is given in this way: log k is equal to 14.2, and this k, and you are asked to EA is equal to what, and k is equal to what if t half is equal to 20 minutes. This is again very simple. You write in this way. It is known to us from Arrhenius equation. We already know that log k is equal to log a minus E naught 2.303 RT. Am I right? And we are given log k is equal, you give it 2. Now if you compare, you will find this part and this part. You are asked to find out E naught. You are asked to find out EA is not it. You just compare these two. You will get, on comparing, these two will cancel out. So EA is equal to 2.303 R into 1.04 into 10 to the 4. Earlier I have already written that this part is constant, and I have shown you the shortcut of these two is equal to 19.1, and you do this part only. This will give you way. Now we need to find out k. Now what is k? We not k is related to t half, so k is equal to at this point here minute should be transformed into second. Again in this part, again you have to do something. I will show you another trick. You forget about the point, just you divide it. I'm not giving any decimal, just I have omitted. So if you solve it out, so this is point, this 0, again this 0. On going solving, you will find the answer is like this. Very simple answer. You will get the answer as this. Now here a trick is there. You see how we'll adjust decimal. Very simple. So above there is 3 unit after decimal, below there is no decimal, means 0. From above to below you minus, you are getting plus 2 answer. If it is plus 2, initial decimal, what decimal is there, decimal should go backward towards 3 unit. Whatever the result, plus result, it will go back. If it is minus result, you will this decimal, initially where is the decimal, you will go towards right if it is minus. If result is plus, move the decimal left of the amount what is you got, what amount you have got. So this is plus 3, so move the decimal 3 unit. So your answer is only this 1 2 3. Now you are getting this answer. So to make it standard unit, what will you do? 1, 2, 3, 4, 5. 7.75 into, this is the answer. Very often if you will be confused to remove decimal and to do this and that, answer will be very bigger. Whenever there is a division, you no need to assume any decimal. You just divide it without decimal, and upper decimal to minus lower number unit decimal, you minus it. If the result is plus, move the result decimal towards that amount of plus, and if it is minus, move this decimal towards that amount of plus minus you have got. This is the answer. So this is all about the today's class. Hope you have enjoyed the class, and as per the request, some of you have requested to upload the class on solution, since your exam is bearing at the door. So instantly within 1 or 2 days I will solve out solution and solid chapter. Thanks a lot for watching the video.